What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. In the ever-evolving landscape of cybersecurity, network attacks remain a constant threat to organizations and individuals alike. Now, understanding different types of network attacks and their impacts, all of this is crucial for IT professionals preparing for the CompTIA Network Plus exam. And in this video, we're going to explore various network attack methods, their mechanisms, and how they impact the security of networks. All right, so let's begin by talking about a denial of service attack, or a DOS attack. And this is a malicious attempt to disrupt the availability of a network, service, or application by overwhelming it with excessive requests. And this results in service degradation or a complete shutdown, preventing legitimate users from accessing resources. And some common DOS attacks include the following. So you have what is called a flood attack. And this is when large volumes of traffic overwhelm a network or a system. You have a SYN flood. This exploits the TCP handshake process to consume system resources. And then you have what is called the ping of death, and this sends oversized ICMP packets to crash a system. Next, we have what is called a DDoS attack, or a distributed denial of service attack. And this is a more sophisticated version of a DOS attack where multiple compromised devices known as botnets work together to flood a target system with malicious traffic. And the impacts of a DOS and DDoS attack are as follows. So both of them cause a disruption of business operations. There's financial losses due to downtime. There's resource exhaustion leading to system crashes. And there's reputational damage for the organizations. All right, so now let's move on to the next one, which is called VLAN hopping. And VLAN hopping, this is an attack where a threat actor gains unauthorized access to different VLANs by exploiting switch misconfigurations. And the type of VLAN hopping attacks are as follows. So you have what is called switch spoofing. And this is when an attacker configures a device to act as a trunking switch to access multiple VLANs. And then you have what is called double tagging, and this is when the attacker sends a packet with two VLAN tags, tricking a switch into forwarding the packet to a different VLAN. So here's the impact of VLAN hopping. So it lets people have unauthorized access to sensitive network segments. There's the potential for data interception and exfiltration. And there's the exploitation of network resources for further attacks. Next, we have what is called MAC flooding, or media access control flooding. And this is an attack that overwhelms a network switch with a large number of fake MAC addresses, exhausting the switch's MAC address table and forcing it to act as a hub. And the impact of MAC flooding is as follows. So the switches, they fail to function properly, which results in degrading the network performance. Attackers, they can eavesdrop on network traffic. And there's the potential for further network attacks, such as an on-path attack. And then we have what is called an ARP attack, or an address resolution protocol attack. And this exploits vulnerabilities in the address resolution protocol, which maps IP addresses to MAC addresses in local networks. And the first type of attack is ARP poisoning. So this is when the attacker sends fake ARP messages associating their MAC address with the IP address of a legitimate device. And this leads to unauthorized access and the interception of network traffic. And then you have what is called ARP spoofing. And this is a form of ARP poisoning where an attacker pretends to be another device on the network. And it is used for on-path attacks or man-in-the-middle attacks to capture and alter data. And the impact of ARP attacks are as follows. So there's unauthorized access to sensitive data, data interception and manipulation, and the potential for a DOS attack. Next, we have what is called a DNS attack. So domain name system attacks, they manipulate DNS queries and responses to redirect users to malicious websites. And within that, we have what is called DNS poisoning. And this is when an attacker corrupts the DNS cache by inserting false mappings between domain names and IP addresses. And then there's DNS spoofing, and this is when attackers intercept and modify DNS responses to misdirect users to fake websites. And here's the potential impact of a DNS attack. So it redirects users to phishing or malware-laden sites. It enables credential theft and financial fraud, and it compromises business integrity and trust. All right, next we have rogue devices and services. So there are unauthorized DHCP and access points. So attackers, they may introduce rogue devices into a network to manipulate traffic and gain unauthorized access. And within that, you have what is called a rogue DHCP server. And this is when an attacker sets up a fake DHCP server that assigns malicious network configurations and it redirects traffic to attacker controlled gateways. And then you have what is called a rogue access point. And this is an unauthorized wireless access point that is deployed to intercept or manipulate network traffic. And the impact is it provides unauthorized network access, there's data interception and manipulation, and it facilitates other network attacks such as evil twin setups. And speaking of an evil twin, so there's the evil twin attack, and this is a rogue Wi-Fi access point that mimics a legitimate access point to trick users into connecting to it. And its impact is it provides man-in-the-middle data interception. There's the theft of login credentials and personal data, and there's also the introduction of malware into user devices. Next, we have what is called an on-path attack, also known as a man-in-the-middle attack. And this occurs when an attacker intercepts and manipulates communication between two parties. And the common techniques are ARP poisoning, DNS poisoning, and Wi-Fi eavesdropping. And the impact is data and theft manipulation, unauthorized access to accounts, and the potential for financial fraud and identity theft. Next, we have social engineering attacks. And the first one we're going to talk about is called phishing. And this involves tricking users into providing sensitive information via fraudulent emails, messages, or websites. Then you have what is called dumpster diving. And this is when attackers, they go through discarded documents or hardware to retrieve sensitive information. There's also shoulder surfing, and this is when somebody observes someone's screen or keyboard input to steal their credentials. And then you have what is called tailgating, and this is gaining unauthorized physical access to a secure area by following an authorized person. And here are the impacts of social engineering. So there's once again the theft of sensitive credentials, the compromise of secure environments, and unauthorized access to networks and systems. All right, so let's move on and talk about some malware attacks. And here's some of the most common ones. So the first one is a virus, and this is malicious code that replicates and spreads. Then you have what is called a worm. This is self-replicating programs that exploit vulnerabilities. Then you have what is called a Trojan, and this is disguised as legitimate software, but it executes malicious actions. Then there's ransomware, where this encrypts files and demands payment for decryption. You have spyware, where this secretly collects user information. And then you have what is called a keylogger, where this captures keystrokes to steal credentials. And the impact is there's system corruption and data loss, financial and reputational damage, and network downtime and productivity loss. So in conclusion, understanding these attack methods is crucial for IT professionals preparing for the CompTIA Network Plus exam. And by recognizing how these attacks operate and their potential impact, network admins, they can implement proactive security measures, including regular security patches and updates, network segmentation and access controls, user awareness training, and intrusion detection and prevention systems. And by staying vigilant and informed, network professionals, they can strengthen cybersecurity defenses and protect organizational assets from evolving threats. All right, now with all of that being said, let's do some check on learning. So the first question is, which of the following attacks floods a switch's MAC address table, causing it to act like a hub and forward packets to all connected devices? Would this be VLAN hopping, MAC flooding, ARP poisoning, or an evil twin? And the correct answer is this will be MAC flooding. So MAC flooding, this overwhelms a switch's MAC address table by sending a large number of packets with different source MAC addresses. And once the table is full, the switch enters a fail open state and broadcasts traffic to all connected devices, making it easier for an attacker to intercept sensitive data. Next question. An attacker sets up a fraudulent Wi-Fi access point that mimics a legitimate one to intercept user credentials. What type of attack is this? Is this DNS spoofing, evil twin, on-path attack, or a rogue DHCP server? And the correct answer is this will be an evil twin. So, an evil twin attack involves an attacker setting up a fake Wi Fi access point with the same SSID as a legitimate network, and users they unknowingly connect to the malicious access point, allowing the attacker to capture login credentials and other sensitive information. And our final question, which type of attack manipulates the resolution of domain names to redirect users to malicious websites? Would this be ARP poisoning, VLAN hopping, DNS poisoning, or tailgating? And the correct answer is this will be DNS poisoning, also known as DNS cache poisoning. And this corrupts the DNS cache by injecting false DNS records, causing users to be redirected to malicious sites instead of legitimate ones. And this attack is often used for phishing, malware distribution, and credential theft.